And we're live. I think can everyone just put their headphones on so you can hear us? And we'll be starting this beautiful breakout session with this beautiful group of people. So my name is Darcy McKenzie. I'm the VP of Global Sales and Marketing for Kolomolo. We're a AWS advanced partner, and we are focused a lot on modernizations, migrations, AI and IoT. And we like to holistically surround and embrace our customers to really go in deep and work together on solving new problems, open up new revenue streams. And today you are going to join us in a conversation with Delaval and Arelion, two of our wonderful customers. And you will see and hear how we helped Delaval and Arelion to optimize their operational efficiency. So without further ado, I'll start with introducing the agenda. Yes.
Are we going to go through the people?
Yeah, we should go through the people.
Yeah, exactly.
That sounds great.
Hey guys, my name's Alex Wheeler. I'm the CEO of Kolomolo. And I'm really happy to be here, and I'm really happy that you're here today to come and listen to us. So I just thought I'd start off this session and just ask everyone, just by raising of hands, who's touched or been working with, directly or indirectly, with Bedrock on AWS? All right, good. So it's around about 30% of the room. So that's going to be really interesting, because what we're going to do is try and show some of the business side of what we've done, and then we're going to talk about the technical side on how we solved that problem. So thanks for coming again.
Amazing.
Camilo.
Hey, thanks, Alex. Yeah, as Alex mentioned, we'll be talking about the implementation into different customers or clients, I'm sorry, Delaval and Arelion. We have a mixture of open source frameworks for AI agents and classic ML for the solutions. We'll go into the technical details in the slides. So thank you for coming.
Hi everybody, Ivo Bogos, Head of Technology and Architecture for Delaval, and I'm here to share a business challenge that we have and that our esteemed partner Kolomolo is helping us solve.
Hi everyone, I'm Joachim Palm from Arelion. I am Head of Operation and Infrastructure, and I'm going to talk a bit about the challenge that Kolomolo helped us solve when it comes to maintenance.
Great.
And now the agenda. So kept it quite simple in terms of the agenda. You will have the business needs for Arelion, then for Delaval, and then you have the technical solution for Delaval, and then we will do the same with Arelion and see how this was helped by us at Kolomolo. And we'll finish with Q&A, so feel free, save your questions for then and shout them out. And we will start with Ivo.
All right, thank you.
Thank you.
Thanks, Darcy. Right, so my name is Ivo Bogos. I've been working at Delaval for the last 5 years almost. I have a background in telecommunications, but when I was trying to sell an IoT platform to Delaval, I realized that they were building something much cooler, so I decided to hop on board and learn about AWS and all the fantastic services that is offering customers like us to build and to create digital services. For those of you who don't know Delaval, maybe a brief introduction, because people sometimes mix us up with other companies in the group. We're part of the Laval group. Delaval are a manufacturer of dairy farm equipment. So you see some of that equipment here. We produce cooling tanks for milk that you might find on a dairy barn, air compressors, and on the top here you see our flagship robot, our milking robot, the VMS, or voluntary milking system. We've been very successful at that. We're a 150-year-old company. But we're seeing a shift with our customers due to different challenges in the market that I won't go into now, but there is a need to make the digital transformation, and our customers, rather than just wanting to buy products, are looking for peace of mind, and they want to make sure that the performance that the equipment that we sell to them is bringing them is guaranteed. So we're building digital services for them now. And you see an example here of a behavior analysis service that we've rolled out to a few thousand customers. What we do is we collect telemetry, so data from the ear tags of the cows into our AWS data platform. And we use machine learning techniques to create, in this case, a prediction of what the optimum insemination window of a cow would be. So by doing this in a very predictive way, the customer loses less genetic material, but also it's important to get your reproductive cycles right, because if you miss a heat, as it's called, you need to feed your animal for another month before it starts to contribute to your top line. So that's what we do. How it is realized in terms of architecture, it's actually just one click. It comes up automatically. So it's not that bad. Quick overview of the architecture. So one of the areas where Kolomolo have been instrumental in my team is the Edge server that you see here. So the Edge server runs a customized Linux distribution that we've built using the Yocto framework. And we run Greengrass for connecting securely to the various pieces of infrastructure on our customers' barns, our sites. And we collect all the data and the information that we need to build these digital services. And also, something that we're now really starting to more than scratch the surface of is we can remotely configure equipment, and we can distribute workloads out to the barn dynamically, for example, depending on maybe vulnerabilities that we found, or maybe dynamically based on subscriptions that the customer has bought. We have a microservice-based architecture, serverless event-driven, so we use a lot of Lambda, we use a lot of DynamoDB, S3 for storage, of course. We're also very big on open source tooling, so we love Grafana, for example, for observability purposes, and many, many other exciting technologies that we use. So it's fun. Of course, Kolomolo do much more, and we'll get into that in a minute. But wanted to share this picture as well that I refer to as our technical backpack. Yeah, this was actually shown to me during my interview process when I joined the company. Basically, every pastel-colored box is one of the systems you would find on a Delaval dairy barn. So it's an incredibly technology-intense company. I didn't realize that to its fullest until I joined. So all of the black boxes you see are industrial computers, but then all of the other icons and machines are somehow connected and talk to each other. For example, just to give one example, to automatically dispense milk to the drain if there's blood detected in it, as an example. Most of this stuff has been around for decades on the farms, but hasn't necessarily been connected, and that's what we're in digital services now starting to do. And as we do that, this year actually we have introduced, as part of our engineering efforts, metrics where we will measure ourselves on how well we are doing in terms of service uptime, SLIs, SLOs. So we're starting to define service level indicators for all the services that we launch, and objectives on how available we want these services to be. So in order to observe in a good way. So we're starting to build a lot of Grafana dashboards, and we're starting to see really some, getting what I've noticed, removing the emotion from some of the discussions if stuff breaks, for example. You can actually look at data and just figure out, okay, we know exactly what's going on. We have a router that's down, for example, and that's why one of the machines can't be reached, let's say. But of course, in addition to monitoring for failure, we also want to make sure that we have a good incident response process in case something does go wrong. And when I say incidents, you can think of that in two ways. There's incidents generated by our systems. For example, alerts that some of the digital services on AWS raise if a heartbeat hasn't arrived in a certain amount of milliseconds, for example. But it's also often customers. If stuff breaks, customers will file a ticket. And then this fantastic support process kicks in. It's a picture that was actually created by a human, not by AI. So all of these boxes, and I removed all of the names, of course, but are basically people calling each other, trying to figure out what the issue was, distributing the issues to the right teams, and trying to figure out, okay, how can we solve this as quickly as possible? And Delaval, a very service-minded organization, so in the end, we will always fix it. But it's challenging, as you can see here, especially with all these products that you saw in the previous slides. Like there's thousands of products that we have out in the market. So how can we do this better? Alex.
Great, thank you. All right. So, I'd like to speak about a product that we've created for our customers, and it's called UnityOps. And I wonder if how many of you guys know Rick and Morty. And Rick and Morty, there's a character called Unity, and Unity is a hive mind, a bit like the Borg in Star Trek. And so I really like this. I'm a big fan of Rick and Morty. It's fun. And so what we built is a hive mind. We have a multi-agent system. So each agent, we train it to be specialized in a specific subject. So one agent could be specialized in looking at your GitHub code. One agent could be specialized looking at your logs. One agent could be specialized looking at the CMDB. One agent could be looking at the previous tickets that you've had. Or one agent can be actually being the master of the conversation between those agents, a manager. So this is what we've built. We've deployed this into Delaval, and we're optimizing the ITSM process. So when we have an event come in, because we're monitoring all of the infrastructure on AWS, we have edge servers running on 3,000 farms right now. We're going to be scaling up to 30,000 farms for Delaval. When we have input from all of these different systems, we want to be able to react fast. And we rely upon UnityOps, that multi-agent system, to look at the state of the infrastructure. It takes a split-second recording. We do run a root cause analysis by having those agents talk with each other. And they speak to each other, and they come out with a root cause. And that goes into the ticket. This is just the first step of UnityOps. Of course, as we get more confidence into the system, as we get more confidence into the output of those root causes, the next step is automation. So that will be the future, where it's a system where the AI will completely run your infrastructure. There'll be an error, and it will go into the logs, and it will see there's an error, this particular line. It will analyze your GitHub code. It will realize that you haven't had a try-catch exception block there. It will put one in, and it will put a merge request for a senior guy to accept that merge request. And we use CI/CD guardrails deployed out onto the infrastructure. So that's the idea of UnityOps.
Well, thanks, Alex, for that incredible overview.
Thanks.
So we need to do a little bit of a history where we were at the moment when we start thinking about how to approach this solution. We were in a moment where most of the industry was focused in a monolithic deployment of an AI solution, meaning a single agent with a user interface where the user is in the loop. And in that way, they interact with the LLM. However, we were looking at what's the things that are happening in the open source community. And at that time, we're talking about the end of 2023, beginning of 2014. There were already some pretty robust frameworks that allowed multiple agents to talk to each other. So a bit of clarification is it's like having one agent set up with a certain rules and a certain task tied to one LLM, and another one in front of him with another task, another LLM, and you put them in a loop to discuss and find a solution for a certain task. Now imagine this is an example with two agents, but now imagine a group. Imagine not only two agents. Imagine a group of several different agents that are working together to solve a business case. For example, we have the multi-agent coding. It's a pretty standard example where you have an agent that specializes in coding. You ask for a certain algorithm, and then you have an agent that's going to review the code, a code reviewer. And it might happen that the code reviewer doesn't agree with the solution that is suggested by the first agent, and then it triggers a clarification loop. So they get into a conversation until they have a consensus, and then they pass the answer to the user. Another conversational pattern that we might have is having a task manager that will receive the task and then it will find the best suitable expert or agent for that given task. Let's say one is for research, let's say another is for a mathematical solution, another is for a RAG implementation. And another one that we will see in details for the implementation on Unity Ops is the dynamic group chat, where we just put a task and we let them all have a debate around it. I would like to mention that these conversational patterns is something that we observe and we take from AG2, an open source framework that is very, very interesting. So let's see a little bit on the architecture implementation. So we have an input and an output. For the case of Delaval, what we have is an alerting platform. It could be your Grafana alerts, it could be CloudWatch alerts, it could be Sentry, you name it. In this case, we use Upsgenie, and we have an integration to AWS via an SNS topic. Could be an API gateway, could be an event bus. And that's the one that triggers or Lambda that is subscribed to this event. Inside of the Lambda is where we have all the agents and all the conversation. We're going to see that in details in the next slide. Each of the agents are also connected to the Bedrock model. Depending on the task they have, we will use one or another model. We also save all the logins or the chat, everything that traces and observability. We save it in DynamoDB, and we interact with the Jira API. Also, we have an implementation of a RAG for two particular things. One is for a playbook retrieval of a given alert. So we need to find what is the troubleshooting steps for that alert that is coming. But also we have a historical search of closed Jira issues that were solved. So we can have a ticket enrichment, have how it was solved at that moment, what was the root cause, and so on. Everything is being deployed on CDK and serverless architecture, event-driven. So now we can see a little bit inside of the Lambda how we have this sorted out. We have two different kind of chats. We have, for the case of the workflow in supporting Delaval, we have an Upsgenie agent, which is the one that once it receives the alert, then it goes to the API, gets all the details from the Upsgenie alert, and it passes to the next agent. There is a format agent. Delaval has a certain format on the incidents once they are reported via Jira issues. We have the knowledge base agent. As I mentioned, one is the one that brings the playbooks, but another one is the one that does all the historical search. And finally, we have the Jira agent, which is the one that consolidates all the information and then it creates an incident. This is a static chat, it's predefined. We know more or less what are the steps that the support group does. However, there is another part which is the dynamic chat, where, for example, when we evaluate historical past issues, we put them in a discussion and they start talking and saying, okay, does this previous ticket is related to this alert? Why is related? Does it belong to the same device? Does it belong to the same farm? What's the root cause? How it's solved? And all that information then is passed back to the main workflow. Again, all of those agents are tuned to different LLM models depending on the task in particular. And finally, we also implemented that observability and metrics page. As I mentioned, we are saving all the chats, tokens, everything that we need to trace the conversations itself between the agents in a DynamoDB table. We use single table design where we put everything with clear access pattern from the beginning. So then we can query by workflow, by agent, by timestamp, And then we presented it at front end. Very important for us was also to show the conversation that is happening with the agent. It happens that the aha moment for many non-technical people or people that wants to understand how this works is seeing the conversation between the agents, how they communicate with each other, how they reach consensus. Thank you.
Thank you. So, to give you guys a little bit of a context on what I'm about to talk about, I need to just explain real quick what Arelion is. So, Arelion is one of the world's largest suppliers of internet. We have a network spanning from Mexico to Singapore. About 70% of all the internet traffic touches our network in some way, shape, or form. So it's a massive network with a lot of customers, a lot of hyperscalers, and a lot of different suppliers. So what we approached Kolomolo with was we are in a position where all our suppliers keep sending us these emails about maintenance, right? Notifications that there will be a link down in Singapore, there will be a link down in France or whatever it is during some maintenance hours. We got a lot of these emails, and it's not just about maintenance. It could be about anything. I mean, whenever they want to talk to us. And we have this inbox that people go through, right? What we do now is that we manually classify these emails. So there is an actual human being sitting there looking at these emails, pointing out what is a maintenance notification and what is not, and then also moving it to the right queue and reading the information and putting it in the system. This, of course, is a resource-intense extraction process because you need a human to interact with the email, you need a human to interpret the information, and you also need to look at whatever is in there that is of importance and when is it supposed to happen. Which means that scaling this, I mean, the more emails we receive, of course, and the more notifications that we receive is impossible. I mean, if the subcontractors start to change whatever they send to us and we need to increase headcount, that's not going to work. That's not going to fly. So looking a bit at the approach that we took, I mean, using AI for this is something that we have been looking at, but we wanted to do a proof of concept together with Kolomolo to see how this one panned out. And it panned out extremely interesting. It was able to classify the different messages. So we then had an idea of what was a maintenance message and what was something else. And it not only did that in the classification, it could also go through the email body and extract the critical information, what service was affected or will be affected, sorry, and where will it happen, how long is the window going to be, how long is it going to be down for, and so forth. And it could also insert a probability. So whenever the AI wasn't sure how to classify something or where it should go, it could create a separate queue where it could relay a probability towards our manual operators so they could classify the email accordingly. And it also pushes the data directly into our CCMT, which is the change management tool, which in turn also pushes the messages out to our customers. So they get notified immediately as well, which means that we not only save time on this, we also have a way of receiving and sending information that is important for business critical carriers or customers, in this case, to accommodate for it in their business and in their day-to-day. So why did we go with AI then? The difference here for us is that these emails comes in various shapes, formats, and different fonts or whatever it is. But they don't have any common way of structure. So we need to adapt to each and every one of the different vendors, which means over 100 different vendors that send different emails. And not only that, it also comes in various different shapes as HTML, XLS, and whatnot. So we need to extract that information from the different formats there as well. A classical approach would struggle with this because as soon as a vendor changes the information in the email, we need to adapt to that with a code change on a classical approach. So that pretty much didn't work for us. It could be something as easy as a space bar somewhere in the maintenance message, and then it would ruin the classical approach altogether. Which means that the AI can adapt to these new forms without a costly maintenance of writing new code or maintaining the old prompts and whatnot. Which is where the rule-based systems are prone to break, right? And as mentioned, the emails, we didn't only want to look at the triggers. We didn't only want to look at something in particular. We need to have contextual information extracted, right? So we need to know the maintenance windows and everything. And that can be scrambled around in the emails for all the different vendors. And if someone has an update somewhere and they scramble it again, that ruins everything with the classical approach. So this is where we saw that AI could be a solution for us. With that, I'm going to hand over to Alex and Camilo to talk about the inner workings of it.
You're next.
Thank you.
Sorry. So we had two challenges. Let's review a little bit the use case. There is thousands of emails coming here to the inbox that they need to be classified, and also they need to have some entity recognition. So for solving this case, we had to come up with a hybrid solution, one that involves classic ML and a new generative AI approach. So some of these emails, for example, they come from all kind of emails, like inquiries, contractual clarification, failures. It comes in different languages, different writing styles. So we needed to find a way, a proper way to find classification and said, okay, the ones that we are interested in are the maintenance notification. Those are the ones that we need to act upon, and those are the ones that we need to identify. So we are going to touch over some of small ML data science concepts. But what we were doing actually for the classification, as I mentioned, is one part is ML, where we do all the classification by vectorizing the email. And then we compare this to a trained model that has a hypersphere of what means and a maintenance email. And then we compare the solution, I mean the email, the vector, how close it is. But it's not only the proximity what we're interested. We are also interested in having a tree of evaluation to effectively know not only, oh, this might be a maintenance email, but also how confident we are. For that, we also use a classification algorithm called XGBoost, which, as I mentioned, not only will compare how close, how's the proximity with this hypersphere in the vector database, but also how confident we are. If something is flagged that, oh, maybe it's not so sure, then it gets passed to a human evaluation. Then the other part, it contains the name entity recognition. This is more GenAI approach, but also we implemented some more mathematical approach to it, especially in the prompting engineering. Um, Also, we have a dual layer bedrock reasoning, so we can leverage some heavy task we pass to a frontier model, while another one can handle classification. It's also more cost efficient. And as I mentioned, some of the things that are being flagged goes to a manual review queue. Mentioning about this automatic prompt optimization, we use the MyPro algorithm. It's something that was researched in the Stanford University, and you can find it in some of tools like the SPY, and maybe some of you might be familiar with it. It allows to have a prompt, the best prompt possible, via mathematical approach. Not only prompt engineering, trying to feed the best prompt for this particular case. It does iterations. It does Bayesian search over the prompt. It evaluates different variants, and then it obtains the most accurate prompt for this particular task. It balances exploration and exploitation. It continuously updates the prompt in case there are some changes in the requirement itself and the task, and dynamically chooses examples for few-shot prompting. As results, we have around 95% of accuracy on classification of the emails. We reduced the time of classification to less than a second. We have the models that can dynamically adapt to different kind of emails. It's impossible to have like a format from those emails. They're coming from all the sides, so it dynamically adapts. It has a fast retraining. It has around 97% of accuracy. As I mentioned, the prompts are auto-optimized using this algorithm. And it increased the confidence scores. Around 80% of the manual workload that Arelion used to do now is reduced.
Great, thanks. So it comes down to cost efficiency of the solution and value to the business, right? So if we're looking at a classical approach using regex patterns, it would just be completely, it just wouldn't work. You'd have 5,000 rules. You'd need to have people to maintain those rules, and it would go wrong all the time, and you wouldn't know when it went wrong. So the cost for the business would be astronomical to that, and it would outweigh what it would cost for a human person to do it. So we have the naive LLM approach, and that would be, let's go use Bedrock directly, and yes, that can be done, or use ChatGPT directly. I shouldn't say that in this hall, but use some form of LLM directly. But the cost with such a high volume of emails, it doesn't make it cost effective again. So what we've done with our solution, we actually have a 10,000% reduction in price for classification of emails compared to a pure LLM. Of course, we're using LLMs. We're using machine learning to actually produce the LLM prompts after classification for the entity extraction. And that pretty much comes to a whole. So what this does is actually brings the cost of doing this operation for Arelion to a very good cost for the business, which would, if it was done by a human, it would cost a lot more. And that's obviously what we're trying to do. We want to make sure that our AI solutions are actually really cost effective and can scale for our customers' businesses. And with this solution, we're using data science to drive the LLMs. So I just want to say thank you very much again for attending. This is the end of our presentation. And I'd love to just open the floor up for any questions and answers. I might not know the answers. Our technical guys would probably know better. But if you have any questions, please feel free. And if not,
I
then,
can start. I have one question.
Yeah,
yes.
Can you still hear me? All right. I would love to see some metrics on those results as well for us. So
Sure.
how much reduction in our support costs are we seeing, for example, thanks to properly classifying system-generated incidents, but also support tickets. That's can be massive, I think.
You can buy the IP from us.
Yeah, and of course we can go into those details. And I know you didn't want to release those exact figures out to the public.
Yeah.
But as Kolomolo, we're actually running on-call SRE operations 24/7. So we have our support staff in Australia. We have support staff in Colombia, Poland, Romania. We have follow-the-sun support to look after the systems. For Arelion, 70% of the world's internet traffic is going over your links, right? So our guys are looking after that infrastructure. So if that goes down, that's the data links that feed AWS data centers, right? It's the links that's feeding a lot of your internet. So if that goes down, then people are yelling at Kolomolo. And so our kind of KPIs on that are quite high, low to react. But the point being is that since we created this system for Delaval, and we're going to be soon implementing it for Arelion, what our SRE engineers can now focus on, instead of just being reactive on tickets all the time, where they can actually spend that time that they've saved. Sure. And we've seen an operational efficiency of 80% of our guys not working on just standard tickets where a machine has gone offline and you're having to go in and check on the router on a farm. Is it because of a power cut? Is it because of a failure on the OS? Is there a breakage in the network? We just automate all of that. And that means our engineers can now focus on other SRE engineering tasks. And so, yeah.
I would like to mention that it's a bit tricky, the KPIs, by the fact that we are increasing the amount of incidents because everything is automated. But we are also decreasing substantially the tickets or the incidents are coming from the client itself.
Yeah.
So it's something that is preventive, and we kind of act upon it before getting a call from the client.
And you keep increasing the number of farms you're deploying on, right?
And also,
it's 3,500 now. I think by the end of next year we'll have 7,000 farms connected, and within 5 years we want to have around 20 to 30,000 farms connected. So it's an increasing problem that we need to solve with engineering tasks rather than just throwing people at it. All right. So guys, thank you so much. A big thank you to Joachim and Ivo for coming here and letting us showcase our solutions. Thank you so much, guys.
Thank you.
Thank you.
All right.
All right. Have an awesome summit.
thanks everyone.